why do these metals matter? Why are we doing the metal examples when we are concerned with biological situations? All right, so metals are totally relevant because they are often bound to proteins, and they are the active site on the protein where a biological redox reaction occurs. Okay? So here's an example of biochemical standard reduction potentials, or half reaction. These are our half reaction potentials. Same kind of thing here. So we did learn about FAD last time. This flavin dinucleotide, I already forgot what A stands for. Don't worry, I have that slide again from last time. Okay? This one is approximately 0 for us now. Okay? So we have, again, things that want to get reduced up on the top that'll have positive values in volts, and we have things that want to get oxidized. So we saw this last time. We saw some protein that had, we said we know iron's attached to myoglobin and hemoglobin. But in this case, we have something called cytochrome C, which actually participates in biological redox reactions, okay? And the site for that reaction is its iron atom, okay? So if you look here, we have cytochrome C, the iron atom, okay? In this case, an iron ion with a 3+ charge gets reduced to Fe2+, okay? So this protein participates in biological redox reactions, and of course the site of that is where the metal ion is. So this is where metals are important to us. They're also just an easier and maybe more readily understood example to get us started before we start seeing fancier molecules on either side of our reaction. Okay? Because, you know, certainly like with pyruvate, if you write it out, it's, you know, CH3, CO, COH. They get really long and sophisticated. So starting with this stuff is just a little bit more straightforward, but it's the same, totally same setup, totally same thing. I did put one metal one on your homework, but the rest are all a biological example, okay? So either you'll be given the values or you can pull them from this table. So something important here is biochemical standard state. It is not the same as regular standard state necessarily, okay? So from table 11.1, which was just our metal half reactions, where we were comparing to a hydrogen electrode as our 0 point. This is the same basic reaction, right? Going from our 3+ ion to 2+, reducing it. We have plus 0.77 here. Here, it's the same thing, but inside the protein, it's not the same number anymore, okay? There are many contributing factors to why that is different, of which we will not get into the details. However, one of those things is biochemical standard state assumes pH is 7. pH of regular standard state would be 0. Okay, and so the reason for that is that if we have a proton participating in our reaction, we would, you know, we could write an equilibrium constant where depending on which way it's going, it's either on the top or the bottom, it's a product or it's a reactant, whatever it might be. We would set this equal to 1 molar for standard state. And pH is the negative log of the concentration of our protons, right? So if this is 1, this whole thing is 0. Standard state pH is 0, but that doesn't really make sense for us biologically, right? We usually denote biochemical standard state with a prime. And so I don't know if anyone in here is also in biochem right now, the MCDB 310 version, and Elijah's not here right now, but he sent me a question yesterday like, oh, we were told our standard tables are like, these numbers are always the same no matter what, and they don't ever change, and you said like temperature could be different, and I'm like, in reality, all of it could be different. Standard state is a constructed concept, right? Again, we made it up so that everyone compares to the same standard, and we can compare our results in a meaningful way, but we still made it up and we can make it whatever we want. And so I said, nothing's really fixed. And so I just want to point that out so you're aware. Okay, I think page 391 in your book talks about this a little bit more, about this biochemical standard state. I will just always tell you, here's the pressure we're at, here's the temp we're at, here's the concentrations we're at, because also the other part that's letting water, the concentration of H2O, be 55 molar, is again part of biochemical standard state, okay? And so usually you want to have the same standards across your discipline. but different branches of chemistry would do different stuff. So I just make everyone aware of that. Okay. So I will hopefully always give you all the information you need so that you know what to calculate. Okay, you have all your properties.